Now, numerical problems from viscosity. So here a metal plate of area 2.5 into 10 raised to minus 4 meter square is placed on a 0.25 into 10 raised to minus 3 meter thick layer of castor oil. If a force of 2.5 Newton is needed to move the plate with a velocity 3 into 10 raised to minus 2 meter per second, calculate the coefficient of viscosity of castor oil. We want to calculate the coefficient of viscosity. Theta is equal to F by A dy by dV numerically. That's equal to F is given, A is, all the values are given, 2.5 divided 0.25 into 10 raised to minus 3 is 2.5 into 10 raised to minus 4 is the area, and 3 into 10 raised to minus 2 is the dV. So this is equal to 0.83 into 10 raised to 3 Newton second per meter square is the coefficient of viscosity of castor oil. Here water is escaping from a cistern by way of a horizontal capillary tube 10 cm long and 0.4 cm diameter. So therefore the radius is 0.2 millimeter. At a distance of 50 cm below the free surface of water in the cistern, so H is 15 into 10 raised to minus 2 meter. Calculate the rate at which water is escaping. We want to find the volume of water escaping. Okay, that means V is equal to pi p r raised to 4 by 8 eta L, and therefore P is calculated by using the formula H rho G. So H is 15 to 10 raised to minus 2, density of water is 1000, that is 10 raised to 3, and G is 9.8. R is given as 0.2 into 10 raised to minus 3. 8 eta L is 10 into 10 centimeter, that means 10 into 10 raised to minus 2 meter. So this is given as here 3.077 into 10 raised to minus 11 by eta meter cube per second. The coefficient of viscosity is not given in the question. That means the rate at which water is escaping is 3.077 into 10 raised to minus 11 by eta meter cube per second. Here a gas bubble of diameter 2 cm rises steadily through a solution of density 1.75 into 10 raised to 3 kilogram per meter cube at the rate of 3.5 into 10 raised to minus 3 meter per second. Calculate the coefficient of viscosity of the solution and neglect density of gas. We have eta is equal to 2 by 9 r square rho b minus rho into g by v. So neglecting density of bubble, and numerically eta is equal to 2 by 9 r square rho into g by v. Rho b is neglected. That is 2 by 9 into r is, we have given diameter, so the radius is 10 raised to minus 2 whole square, and rho is 1.75 10 raised to 3, and g is 9.8, and velocity is 3.5 10 raised to minus 3. So we are getting 108 Newton second per meter square as the coefficient of viscosity. In this problem, water flows through a pipe of 0.04 meter radius and 2 kilometer in length at the rate of 100 liter per minute. So it is given as 100 liter per minute. So V by T is 100 per 60 liters per second. Determine the pressure required to maintain the flow if the coefficient of viscosity is 10 raised to minus 3 Newton second per meter square and atmospheric pressure is 1.01 into 10 raised to 5 Newton per meter square. So we want to calculate the pressure. So P is 8 eta L by pi r raised to 4 into V by T. Okay. So this is from Poiseuille's formula. So therefore 8 into eta is 10 raised to minus 3 into L is 2 into 10 raised to 3 by pi is 3.14 into 0.04 all raised to 4. V by T is 100 by 60. So that gives 3.317 into 10 raised to 6 Newton per meter. This is the pressure. If you divide it with 1 atmospheric pressure, you can calculate the pressure in atmosphere in atmospheric pressure. Anyway, the pressure is 3.317 into 10 raised to 6 Newton per meter square, or the Pascal. So here in a Poiseuille's capillary flow method of determining the coefficient of viscosity of water, 50 cc of water is collected in 6 minutes. So V by T is 50 cc means centimeter cube. So we want to make it meter cube. So 10 raised to minus 2 whole cube, that is 50 into 10 raised to minus 6. 6 minutes, 6 into 60 second. Therefore volume per second is 50 into 10 raised to minus 6 by 6 into 60 meter cube per second. If the head of water used is 0.4 meter, that is H is, and length of the capillary tube is 80 centimeter. Therefore H is 0.4 meter and L is 80 into 10 raised to minus 2 meter. And the radius of capillary tube is 0.5 millimeter. Estimate viscosity obtained in the experiment. So eta is pi p r raised to 4 by 8 L into V by T, that is 3.14. P is H rho g. 0.4 into 10 raised to 3 is the density of water, into G is 9.8. R is given as 0.5 into 10 raised to minus 3 all raised to 4. 8 into 80 into 10 raised to minus 2. 6 into 60 by 50 into 10 raised to minus 6. On calculating, we have 0.865 into 10 raised to minus 3 Newton second per meter square. Here a liquid flows through a horizontal tube of length 0.2 meter and internal radius 10 raised to minus 3 meter. Under a constant head of the liquid 0.2 meter high. If a time of 10 minutes, 6 into 10 raised to minus 3 meter cube of liquid is coming out of the tube. That means V by T is 6 into 10 raised to minus 3 by 10 minutes, that is 10 into 60 seconds. Determine the coefficient of viscosity of the liquid of density 0.9 into 10 raised to 3 kilogram per meter cube. So eta is given by pi p r raised to 4 by 8 L V by T. So 3.14, P is H rho g, 0.2 into rho is given as 0.9 into 10 raised to 3. So on calculating, we have 0.346 into 10 raised to minus 3 Newton second per meter square as the coefficient of viscosity. Here the terminal velocity of a copper ball of radius 2 millimeter falling through a tank of oil at 20 degrees Celsius is 6.5 centimeter per second. Okay. Compute the viscosity of the oil at 20 degrees Celsius. Density of the oil is 1.5 into 10 raised to 3 kilogram per meter cube and density of copper is 8.9 into 10 raised to 3 kilogram per meter cube. We have eta is equal to 2 by 9 r square rho b minus rho oil into g by v. So substituting all the values are given. Substituting them, we have eta is 0.992 Newton second per meter square. So here a capillary tube 10 raised to minus 3 meter in diameter and 0.2 meter in length is fitted horizontally to a vessel kept full of alcohol of density 0.8 into 10 raised to 3 kilogram per meter cube. The capillary tube is 0.3 meter below from the surface of alcohol in the vessel. Calculate the volume of alcohol. Eta is given for 5 minutes, that is 5 into 60 seconds. So V is equal to pi p r raised to 4 T by 8 eta L. All the values are given. 0.3, P is H rho g. We have 7.21 into 10 raised to minus 6 meter cube. Here, in giving a patient blood transfusion, this is the blood transfusion that you have seen. The bottle is set up so that the level of blood is 1.3 meter above the needle. So H is 1.3 meter, which has an internal diameter of 3.6 into 10 raised to minus 4 meter. So R is 1.8 into 10 raised to minus 4 meter, and is 0.03 meter in length. If 4.5 into 10 raised to minus meter cube of blood passes through the needle in 1 minute, so V by T is 4.5 into 10 raised to minus by 6 by 60 meter cube per second. Calculate the viscosity of blood if the density is 1020 kg per meter cube. So eta is pi p r raised to 4 by 8 L V by T. Substituting all the values, we have 2.4 into 10 raised to minus 3 Newton second per meter square.